Hello and welcome back. Last week we added in some changes to the respawn of the asteroid. This week we're going to track the player's score as they play the game. Just a quick note, we've posted the most recent code build to itch.io so you can get the latest Windows build from here. Keep an eye out as we'll add in the latest code when it's ready, and we'll also release for Mac and Linux soon. Check out the link below. To get started, let's check that we have the code from the previous session running by running cargo run. If the code isn't like this, then you can do git checkout tutorial 12 to get the previous code. First, we'll go to the components.rs file. Then we're going to add a new component type. First, we'll tell it to derive component. Then we create the new struct called gameData, and we create a variable called score of type U32. Then we navigate back to our main.rs file. And here we register the new type in this file by adding it underneath the other registered types. And then we will need to initialize this, so we switch back to game.rs and scroll down to the load world function. Underneath the call to create asteroid, we're going to create the new entity. And it will have a component type of components gameData with the initial score being set to 0. And we finalize it with .build on the end. Next up, we're going to go to missile.rs and scroll down to our Missile Striker implementation. And we'll add in a reference in the type data to the newly created type of gameData. And we need to ignore that down below as we break out data on the first line of the run function. Then we'll need to create a mutable local variable to keep track of the score inside the loops. We will call this score. Give it a type of U32 and an initial value of 0. Now, whenever we see a collision between the missile and asteroid, we will add 10 to the score. Then, scrolling down in the function, we add in another underscore to ignore the new gameData type as we break out the data again. At the end of the function, we're going to loop through the gameDatas by getting a reference to the gameData components. We will ignore all of the other types in the data object, so there will be a lot of underscores, but with a mutable reference to the gameDatas. Then we make a loop by using for gameData in gameDatas, making sure to make gameDatas mutable, then calling join on the single object, although there should only ever be one. And then, as you might have guessed, we take the gameData.score and add the new local variable of score to it. And we run cargo build to make sure it builds with no warnings or errors. And it does. So we'll go back to our main file and scroll up to the render function. We'll be using the texture creator so we can remove the underscore from in front of the variable in the argument list, and we do the same for font. Then we scroll to the bottom of the function. After the code, but before the canvas.present call, we will grab a reference to gameData by getting all of them, although there should only ever be one. And underneath, we will loop through the gameDatas by calling for gameData in gameDatas.join again. We'll just leave a little comment here to say that we're showing the score. And then we will create a string variable to hold the score. To save us making it mutable, we will concatenate the string as we assign it. The first part is a string with the toString method called on it, and then we can simply add an @ reference to the gameData.score, calling the toString method on that as well. Then we will create our surface, as we did in one of the previous tutorials, by assigning the result of font.render and passing in a reference to the score variable we created above. Then we call blended, passing in the red color with a 50% transparency, making it 128. And finally, we map any errors by calling toString on the error, not forgetting the question mark on the end to remove the compile time warning. Then we turn the surface into a texture by assigning the result of textureCreator.createTextureFromSurface, passing it a reference to the surface above. And we similarly add in a map error section and put a question mark on the end, as before. Then we create a variable called target by initializing a new rect with an x and y coordinate of 10 and 0 respectively. These are of type I32, and we give it a width and height of 150 respectively. these are of type U32. Then we call canvas.copy and pass in the texture, none for the second argument, and finally the target rect, wrapped in a sum call. And that's it, so we call cargo run. And we can now see our string being displayed. When we shoot the asteroid, the score goes up, as we'd expect. To get rid of the last compiler warning, we need to add in the question mark on the end of canvas.copy, which we forgot before, and run cargo run again. And we see we had no compiler warnings. The game operates as we'd expect, displaying the score in the top left corner and continually counting up every time we manage to shoot the asteroid. Join us next time when we'll be looking at ways to further increase the difficulty of the game by increasing the number of asteroids on the screen at any given time, essentially making the game progressively harder. If you enjoyed the video or have any questions, please leave them in the comments below. Don't forget to subscribe to the channel and check the notification button to make sure you get notified when the next video is out. But for now, I'll wish you a good day and hope to see you again soon. Bye for now.